All right, let's dive right into this explainer. Today, we're unpacking something absolutely crucial, the macroeconomic objective of legal engineering. Basically, we are looking at a fundamental evolution in how society governs itself. And honestly, the core of this transformation is entirely about reducing friction. You see, in every industry on Earth, legal disputes, contract drafting, and compliance act as a massive hidden energy cost. It's a literal tax on human cooperation. Every single time a deal stalls in red tape or requires hundreds of billable hours just to verify terms, economic velocity slows down. So what we're going to explore today is how mechanizing and automating legal performances can dramatically slash those societal transaction costs, ultimately acting as the ultimate economic lubricant for modern global trade.
To really wrap our heads around this, we actually need to ditch that old static paper mindset and shift to a much more dynamic, calculus-based perspective. Traditionally, lawyers think of a performance as people just fulfilling their contractual obligations written on a dead tree document that's stuffed in a filing cabinet somewhere. But legal engineering, it bridges law with computer science by treating this as a runtime, the actual active execution of digital instructions. For a lawyer, a contract is a record of promises. For a developer, a runtime is an active environment where code executes securely. Fusing these two concepts means we're shifting away from retroactive enforcement and moving toward proactive, localized logic that just processes itself automatically.
Think of it like a composer orchestrating a musical score. A composer doesn't try to write the music while the orchestra's already on stage playing their instruments, right? No, they design the entire system beforehand, carefully structuring verses, setting tempos, looping choruses. And in this new paradigm, legal engineers do the exact same thing. They map out the rules, set the dependencies, hit play, and the performance executes autonomously. The contract isn't just a physical artifact of an agreement anymore, it's the actual engine. It becomes a localized micro-jurisdiction that forces the agreement to execute perfectly, start to finish, with absolutely no human intervention.
Okay, moving on to Section 1, the timeline of legal evolution and mapping the paradigm shift.
To intuitively grasp exactly where we're going, we can actually map this history perfectly to the evolution of transportation. In the past, we operated in the horse and buggy era of direct law, traditional, analog, slow-moving lawyering. Today, we are firmly entering the car era of mechanized law, which brings hyperspeed through code. And finally, we're steering toward the ultimate goal, automated law. Think of this as the Waymo era, featuring fully autonomous, self-executing systems. Now, it's really tempting to think we can just jump straight from paper contracts to autonomous robot lawyers, but you simply cannot skip the mechanization phase. Just as you can't deploy an autonomous vehicle without first inventing the engine, the chassis, and paving the roads, we have to build the mechanized legal infrastructure first.
But here's the catch. Just as early cars brought this unprecedented speed, they also brought entirely new, fatal dangers. Think about it. In the horse and buggy days, a broken wooden wheel was just a nuisance, and simple buyer beware rules worked totally fine. But a wooden wheel on a vehicle traveling 40 miles an hour, that's literally a lethal hazard. That technological leap essentially forced the invention of modern negligence torts. Well, similarly, mechanized law moves at hyperspeed compared to traditional paper. If an automated smart contract has a critical bug and executes at 1,000,000 miles an hour across a global financial network, the macroeconomic damage is catastrophic. Because of this, mechanization demands entirely new regulatory guardrails and rigorous engineering standards to ensure our systems don't just crash the economy.
Next up is Section 2, the mechanics of modular law and building a more efficient system.
So, the really crucial point here is that Ricardian contracts serve as the critical bridge to this new reality. They're this brilliant innovation because they format a legal agreement to be simultaneously machine-readable and text-readable by human lawyers. By utilizing cryptographic hashes that are securely linked to standardized human prose, they allow nuanced legalese to interface directly with deterministic machine code. This ensures that the robust, time-tested logic of traditional jurisprudence isn't lost. Instead, it's seamlessly linked to the automated execution, instant settlement, and perfectly transparent accounting of digital network systems. Now, by treating contractual clauses as modular dependencies, we create what's known as contract chaining. And honestly, this is where the macroeconomic efficiency just completely skyrockets. Imagine a foundational boilerplate clause, like say an industry-wide indemnity standard is legally updated. The system instantly checks for permissions and dependencies, and then every single downstream contract connected to that specific module automatically updates, or it cleanly flags a break. This domino effect completely eliminates the manual labor of armies of associates auditing and updating thousands of individual agreements one by one. The sheer volume of saved billable hours fundamentally rewrites the cost of corporate compliance.
Of course, to make this leap, traditional practitioners have to overcome some classic grammatical hurdles. A perfect example is learning the distinct difference between assigning a value and checking for equality. Lawyers are rigorously trained to read standard English prose left to right, but in programming syntax, variable assignment is actually read right to left, and conditional statements are heavily nested within brackets. Grasping these simple data-type primitives and Boolean logic operators is absolutely essential. It's really the only way to effectively translate verbose legal drafting into clean, collapsible, and deterministic code that a machine can execute flawlessly.
Which brings us to Section 3, reducing social transaction costs and the macroeconomic impacts.
Let's put this into perspective. During the 2008 financial crisis, lawyers were dealing with massively complex omnibus agreements for asset-backed securitizations. When the crash hit, total chaos. Law firms literally had to physically dig through endless paper archives and warehouse boxes just to untangle who actually owned what. The memory of the deals was buried, creating massive, cascading societal friction that essentially froze the global economy. We see similar, though maybe less catastrophic friction, in the entertainment industry, where popular music catalogs are routinely double assigned by mistake because paper chains of title are impossibly messy. Mechanization replaces all that physical digging with instant, transparent dependency updates, acting as the ultimate economic lubricant.
Think about how the Visa network completely eliminated the high friction of local bartering and carrying cash, suddenly enabling modern, high-velocity global trade. Well, mechanizing legal performances does the exact same thing for the hidden energy costs of business operations. When legal rules execute perfectly and automatically as runtimes, you drastically lower the barrier to entry for establishing trust between strangers. You entirely bypass the millions of hours and billions of dollars previously wasted on administrative overhead, manual auditing, and drawn-out legal discovery. The capacity for global trade scales exponentially when the friction of establishing trust is completely removed.
Finally, let's look at Section 4, the future legal profession and adapting to the automation era.
As this technology lowers the barrier to entry, the very definition of a legal practitioner is actually going to fracture into two distinct paths. First up, we've got the engineering path. Here, software developers who possess a deep understanding of cybernetics and cryptography will act as specialized legal authorities. Much like how highly technical patent agents operate alongside patent attorneys today, these developers will be the acknowledged authorities in deploying secure, legally binding digital infrastructure. On the flip side is the lawyering path. Traditional practitioners will naturally evolve to write and operate directly in programming syntax, transitioning their value from drafting static prose to deploying highly reliable, active software architecture.
So as we fully embrace this calculus of law, the real question becomes one of governance and trust. When the legal rules governing your life, your property, and your business are finally automated and executing at hyperspeed, who do you actually want behind the wheel designing those systems? Is it a traditional lawyer who has painstakingly learned the syntax of machines? Or is it a computer developer acting as the new legal authority of our digital age? It's a fascinating crossroad, and the path we collectively choose will dictate not just the efficiency, but the foundational safety of our future economy. Thank you so much for joining me on this explainer. I hope it has given you a completely new perspective on the intersection of law and code.